Ready to solve the first problem on rotational motion? Let's do it. What is the problem? A ball of mass m, this mass m is given of the ball of mass m, is swung around a circle at the end of the string of length L. Length of the string is given, and this ball goes around the circle. That's not a circle. We can do better a little bit. Okay. Now, this string will break if the tension in it exceeds a critical value Tc. If I exceed this tension, this force that is equal to this Tc, then the string will break. This is top view. Top view. What is the largest constant angular velocity the ball can have without breaking the string? So I'm spinning it, and what is the largest omega? Omega maximum. That's what I need to find right before this string breaks. So what will we do? Well, I know something about force. I'm looking for omega. Why don't we use our Newton's second law to solve this problem? So let's draw the free body diagram. Force of tension is towards the center. This is force of tension T. This is view from above, so there will be force of gravity that will be into the board and normal force that will be out. And my coordinate system, that's what I need immediately. I will go, as always, with unit vector IR that is along the radius, and I theta that is perpendicular to IR. And now I'm ready to write the second law. So what is F sub R? For my case, F R, net radial component of the force. It is MAR, and it is equal to M. And then since this is a circle, then d2r by dt squared is 0. And then what I have is minus r omega squared. R is L, and then omega squared. What about F theta? F theta. For F theta, I have dr dt 0 because my radius is constant. And what about omega? Omega is constant, then alpha is 0. I'm spinning it with constant omega. Then alpha is 0, which makes F theta 0. We have net force in radial direction. And we know the magnitude of this force when we need to find omega. It is Tc, and the direction is towards the center. So the projection of the force on my radial direction, positive radial direction, is negative. Minus Tc is equal to minus M L, and this omega is omega maximum that we are looking for, omega squared, minus minus plus, and then omega maximum omega that I can afford right before the string breaks will be Tc divided by M L and square root. We found omega maximum. If the numbers are given for the force T, C, M, and L, we plug in the numbers and we know the number for omega. We have unknown on the left and all known quantities on the right. Problem solved.